astronomers have found a giant planet in one of the most observed star systems near Earth. But Webb did not discover it as a clean point of light. The planet first revealed itself through the chemical fingerprint of its atmosphere. The system is called Beta Pictoris. It lies about 63 light-years away in the constellation Pictor. That is close enough for astronomers to separate unusually fine details around the star, yet far beyond any spacecraft we could send. Beta Pictoris is only about 23 million years old. Our Sun is roughly 200 times older. The system therefore acts like a nearby laboratory where astronomers can watch giant planets interact with debris left from their formation. Its dusty disk became famous in 1984 as the first debris disk imaged around another star. Dust from collisions continually traces the architecture of the system, making invisible gravitational effects easier to see. The first known giant, Beta Pictoris b, became one of the earliest exoplanets seen directly. It is massive, young, and hot enough to glow in infrared light, allowing telescopes to distinguish it beside its much brighter star. A second giant, Beta Pictoris c, was first inferred from the star's changing radial velocity and later imaged. Its gravity makes the star move slightly toward and away from Earth, shifting the wavelengths of the star's light. With the new planet D, Beta Pictoris became only the second known planetary system with at least 3 directly imaged planets, after HR 8799. That makes it unusually valuable. 3 worlds can be compared inside the same birthplace. The Webb team was not searching for another planet. They pointed NIRSpec at planet B to examine its atmosphere. During that observation, an unexpected signal appeared farther from the star, inside a region dominated by scattered dust. The key instrument was NIRSpec's integral field unit. Instead of recording only brightness at each pixel, it also spreads that light into a spectrum. The result is a 3-dimensional data cube, 2 directions in space, plus wavelength. Beta Pictoris d remained hidden because the system contains one of the brightest known debris disks. Dust scatters the star's light like fog around a headlamp, creating glowing structures that can imitate, cover, or overwhelm a faint planet. An orange blob appeared in the reconstructed image, but researchers did not trust it. A bright spot can be an instrument artifact or a knot in the disk. A picture alone could not prove that the source was a planet. The spectrum changed everything. Where reflected dust should produce a relatively smooth signal, Webb recorded repeating peaks and troughs. Their spacing matched molecular absorption lines expected from the atmosphere of a cool giant planet. The clearest initial fingerprint came from carbon monoxide. Across roughly 4.5 to 5 microns, many narrow lines combined into a distinctive barcode. Dust can scatter light, but it cannot easily reproduce an entire planetary molecular pattern. Those same lines also carried motion. When an object moves toward or away from us, its spectrum shifts slightly through the Doppler effect. Webb therefore measured not only chemistry, but the radial velocity of the hidden source. Its speed, position, and alignment matched an object orbiting Beta Pictoris. They did not match a distant background star or brown dwarf projected into the scene. Chemistry and motion pointed to the same conclusion, a third planet. A second NIRSpec observation confirmed the source at another point in its orbit. Repeating the detection matters because real planets move predictably, while random noise and many optical artifacts do not survive across instruments, dates, and observer conditions. Follow-up observations with Webb's MIRI instrument found water vapor and methane, while the combined spectrum also contained carbon monoxide. Multiple molecules strengthened the planetary interpretation and began turning a discovery into an atmospheric study. At the same time, an independent team detected Planet D with ESO's Very Large Telescope and confirmed it in Webb NIRCam and older VLT data. 2 methods, 2 teams, and several instruments converged on the same world. Once astronomers knew where to look, they found the planet in archived observations reaching back about 11 years. In 2014, planets B and D appeared almost aligned from Earth, allowing the fainter world to hide beside its brighter neighbor. Planet D is about 100 times fainter than Planet B. Corrected for distance, ESO describes it as the faintest exoplanet directly imaged from Earth. Its low brightness helps explain why so many earlier images failed to identify it. Current imaging models estimate a mass near 2.4 Jupiters, with an uncertainty of roughly 0.6. The spectroscopy analysis allows a broader range of 2 to 4 Jupiter masses. Either way, D is the lightest known giant in this system. Atmosphere and evolution models place its effective temperature near 600 Kelvin, about 327 degrees Celsius. That sounds hot, but for a young self-luminous gas giant, it is relatively cool and therefore difficult to image. The independent orbit fit gives a semi-major axis near 26 astronomical units, while the spectroscopy study favors more than 30. The uncertainty remains large, but both place the planet at a distance comparable to Neptune's region around our Sun. The orbit is inclined about 89 degrees to our line of sight, almost perfectly edge-on. That geometry compresses planets and disk structures into the same narrow band on the sky, increasing overlap and making faint objects harder to separate. Planets C, B, and D appear broadly coplanar, with D outside the other two. This ordered architecture matters because it records how giant planets formed, migrated, and exchanged angular momentum while the system was still young. Debris disk begins with a surprisingly sharp inner edge. Before D was found, the two known planets did not fully explain that boundary. The new planet occupies the right general region to account for the missing gravitational sculptor. A planet does not physically sweep dust like a solid blade. Its repeated gravitational pulls destabilize nearby material, scatter particles, and maintain gaps. Over time, that invisible influence can carve a clean edge into an otherwise broad debris disk. Researchers had already proposed an additional outer planet to reproduce the disk's structure. The prediction was not an exact photograph of D, but the discovery shows how debris can act as indirect evidence, revealing planets through the shapes their gravity leaves behind. Imaging colors indicate strong carbon dioxide absorption and suggest an atmosphere enriched in elements heavier than hydrogen and helium compared with similar free-floating objects. Those conclusions are model-based, but they offer clues to the planet's formation history. Planet D is not shining because it is a star. It glows mainly by releasing heat, retained from formation and ongoing contraction. Converting that luminosity into mass depends on evolutionary models, which is why different analyses report ranges rather than one perfect number. The breakthrough was spectral template matching at moderate resolution. Researchers searched the data cube for a coordinated forest of molecular lines, not merely a bright pixel. Beta Pictoris D is the first planet discovered primarily with this approach. It matters beyond one system. Broadband images combine many wavelengths, so dust and planets can blend together. A spectrum isolates patterns unique to atmospheres, potentially revealing colder, fainter worlds inside bright disks where normal imaging struggles. The beautiful system portrait is an artist's concept, not a conventional close-up photograph. NASA notes that the orbital distances are shown proportionally, but the planets are enlarged. The real detection is the faint signal and spectrum behind that reconstruction. Important details remain uncertain. More observations are needed to refine the orbit, temperature, gravity, and chemical abundances. Astronomers must also test exactly how strongly Planet D shapes the disk and whether still smaller worlds remain hidden. Beta Pictoris D was hiding inside data astronomers had studied for years. Webb found it by reading its air, and archives confirmed its motion. The lesson is powerful. The next unseen planet may already be present, waiting for the right match.